Okay, in this lab we're going to examine variables to start with, which is really part of the in-class lecture, and then we're going to look at how to address in-class lab 1. So let's get started with the variables. I've got a little PowerPoint slide here that I'm just going to kind of talk you through. Just remember that in any language, but especially in 150 where you're getting started with this, anytime you think that you're going to have to hold on to something, either a program either generates, gets from the user, or outputs, you're typically going to have somewhere to store it in memory, because everything is stored in memory, whether it be your program or data or whatever. So as a programmer and developer, it's up to you to decide how many variables you need, what you call them, and what they're going to do. So the place that these are stored is in RAM, which you know is random access memory. And essentially what happens is when you declare a variable, which we'll look at momentarily, you're going to give it a name and a data type. And in CIS 150, we're always talking about one of two types. It's either numeric, meaning it can hold a number, or string, meaning it can hold some number of characters, like your first name. Mine is Tom, so a string holding Tom would have 3 characters in it. And that name basically points to a memory location that is worked out between your application and the operating system, so that whenever you use that name, it always points to the beginning address in memory, and it allows you to have access to that memory address without having to worry about the hexadecimal, values and all that stuff. So when you declare it, it basically doesn't hold a value. It holds a hexadecimal starting address of the memory location in RAM that's allocated by the operating system when the program is loaded. So every time you declare a variable in your code, when you run that program and it's loaded into memory, it automatically allocates enough memory in conjunction with the operating system to hold all the different types and variables that you've declared. There's a little bit of difference between variables and constants. Constants are actually the same process, use the same process as a variable, only once you initialize that memory location to a value, you cannot change it as long as that program is running. So it's constant in that regard. Uses the same mechanism as a variable declaration. It's just that once it's assigned a value, it cannot be changed. Constants have a little different naming scheme. And if you look on this PowerPoint here, you'll see that I've got a underscore constant. You can have ABC or 1, 2, 3 or whatever. You can't have any spaces, and they're typically by default, they're always uppercase, whereas a variable uses what we call camel casing, which we're going to look at in just a moment. So here's some variable naming conventions. Camel casing. If the name of the variable is just one word, it's all lowercase, like name. Okay. If it's more than one word, the first word is always lowercase. Each subsequent word begins with an uppercase letter. First, all lowercase, and then the next word, name, starts in uppercase. So if I had, 3 words here, the first one would begin with all lowercase, and then the subsequent 2 would all begin with an uppercase letter for the first character of each word. Hence the name of the camel casing. It kind of follows the humps for each one of those words. We talked about name constants. Here's a little graphic I've set up that shows you essentially what happens in memory. Not so much syntactically, because that varies from language to language, but this kind of applies to all of them. This is what we call a variable declaration, and it consists of a data type, a variable name, an assignment operator, and a value. So when you declare a variable, you're not only going to declare it and tell it what type, but you're also going to give it a default value, and there's a reason for that, which I'll get to in a moment. So this particular variable is of type integer, but in CIS 150 we're not worried about specific numeric, specific string. It's either going to be number or string. Okay. In this case, it's a numeric type, and we've called it month. That's the name of the variable location. Now, when you say month has a value of 1, that's not necessarily true. It actually means that month points to a memory location, the starting address in memory, a hexadecimal address, big enough to hold the numeric type. Okay, that's what that means. So when the compiler sees this, says, okay, this is a variable declaration, meaning I have to work in conjunction with the operating system and find a block of memory that's big enough to hold a numeric type. In this case, probably 4 bytes long, right? And then it takes this name that you've come up with. I've just used name. It could be whatever, year, my integer, who knows, whatever it happens to be, and points that name to the starting address in memory that it just, in conjunction with the operating system, allocated to store this number. All right. Then and only then does it see this assignment operator. Now, in the context of creating variables and assigning variables values to memory, this is always considered in this context an assignment operator. It is not. Remember, it is not a test for equality in this context. It is in other contexts, but not this. Whenever the compiler sees this, and whenever you see this, when you're assigning a value into a variable name, you always think of it this way. This is the rule. You take whatever's on the right of the assignment operator. So what's on the right of this assignment operator? The numeric value of 1. All right? Now, it has to be one value over here. It can't be 3 values or 5 values or something. So if it's logical, it'll come up with a true or false. If it's an arithmetic expression, it'd be 1 plus 2. That would be 3. So it would do the math first. It has to resolve the right side of this assignment operator into one and only one value. Once you see one value here, then the rule is take whatever's on the right of this assignment operator and push it over into the memory location pointed to by the name on the left. So where does month point to? Right here. So what goes in this memory location? 1. All right, let's look at this again. Just repeat this so it'll get in your noggin. You take whatever's on the right of the assignment operator, assuming this is only one value, has to be one value, and stick it in the memory location pointed to by the name on the left. Well, the name on the left points to the starting address. That's how we have access to this memory location. That's pretty much it. And you might want to look at this several times until you kind of get a handle on it, but that's pretty much it. So let's go to the next slide. Now notice I initialized that variable, the memory location to that variable with a value of 1. It could have been 0. It could have been any number. Now why do we do that? Well, Microsoft states in their official documentation for Visual Studio, in most of the language anyway, that they will automatically initialize a memory location pointed to by a variable name to 0, or if it's a string, to an empty string. You can't count on that. And especially in my class, you have to initialize those values, those variables, some default value. If you don't, I'm going to bleed all over it. Okay? You have to get in that habit. Do not forget to do that. And here's why. When the operating system allocates that block of memory for your variable that you just created, there's going to probably be garbage in there, ASCII values, numbers, program code from some other program that used that before. If you don't wipe that out with a default value, initialization value, you might accidentally, or your program might accidentally try to take that garbage and do math with it or something like that. It's going to cause a huge problem. So always wipe out that garbage by giving it a default value. That value, if you don't know what it is, sometimes you do, most of the time you don't, just as a starting value to wipe that garbage out. If it's a numeric, give it a 0. If it's a string, give it an empty string, quotes, close quote, and we'll talk about that later, so just keep that in the back of your head.